The, out of the, well, I guess it's 137 is the actual number. And the vast majority of them, or the majority of them, are in the amorphous silicon. A lot of these are there because of the ease of entry into the business using equipment from Applied Materials, Oerlikon, Ulvac, and others to get into the business. The remaining companies, as a rule, are having to develop their entire production chain into, and their entire production process independently. So by sort of the limited pool of technical talent and the time it takes, it takes them a little while to get going. And therefore there are less of them. CAD-TEL leads thin film deployment. First Solar's announced, essentially, if you go back and read their management statements, that their costs will be below $1 a watt by the end of 2009. So for everybody that voted, they've already announced that, but you have to kind of tease it out of their management presentation. Amorphous, two ways to do amorphous. You've got the amorphous on glass, which is what I think Charlie at Applied Materials will talk about today, as well as Oerlikon. And but you've also got the multi-junction on stainless steel. That's unisolar. So you can do amorphous either way, and there are advantages and disadvantages. These are some of the Applied Materials customers that have announced or that we've been able to interpolate from publicly available information. But one of the things that the chatter, whether it's true or not, the chatter these days has been how quickly is the efficiency improving, and I hope we'll get some clarity or some additional clarity on that today, but there's been some real concerns about the degree to which the product is meeting its efficiency thresholds. It's not unique to Applied. Almost everybody on the amorphous side of the business is plagued by chatter and rumors about low efficiency. So Oerlikon has been, and certainly with them moving from, with Airsoul, their first kind of big customer, moving from their single junction to the tandem junction product in the first stage before even releasing things to the commercial market, has only added to the chatter. And finally, SIG's technology is is a set of technologies and a set of companies that have been venture-backed and predominantly some through corporate venturing, as we'll see in the case of Q-Cells, but also a lot of U.S. venture capital-backed companies that are getting ready to really break out. And never far behind, China, the Chinese manufacturers have a long list of potential competitors in the thin film space to help drive the costs down further using their cost advantages. So here's our forecasts. These are open for discussion. We may even update them real time by the end. I'll get my cell phone and I'll dynamically update my own forecasts over the course of the day. We have a potential production, which really is announcements plus growth. We have our projected production, which derates these companies pretty heavily, somewhere between 60 and 85% for those that even make it onto the list of viable producers. Our projected production had been 3.3 gigawatts. It is now 4 in 2010. A lot of 75% of which is represented in this room today. So we'll actually get a lot of transparency into this number, but just based on the presentations we'll see today. The potential production is 17 gigawatts by 2012. I don't believe that number will happen. I think that's the best. But I tell you, so that by 2010, the relative economics could really set this up. This is another slide where you look at the projected production by technology type. We have, CAD-TEL is a dynamic player, but it's really driven predominantly by a single company. SIGs, we show, a half a dozen to 10 companies. And amorphous, because of the vast number of companies involved in the amount of equipment, the volumes are pretty high. So this is our projected production. So this is derated and everything. Here's substrate types. It's important because some things are glass only, and some things are glass and flexible. And some things that are flexible are then put on glass to make it a form factor that's easy to use by the downstream installers and integrators. And really that's going to drive the market through 2010. But those that have flexible substrates on the and who can deal with the packaging problems that those sometimes create may have the opportunity to create new form factors in the years to come, and that's going to be an interesting discussion point. It's not obvious, though. The surge of these are the number of commercial producers. You can see the number of amorphous producers. The easy way to think about this is 20 companies cross the commercial threshold, meaning more than 5 megawatts of production capacity each year for the next 3 years. So 3 years from now, by the end of 2010, we will go from 10 companies that are at the commercial threshold for thin film to 70 companies that are at the commercial threshold for thin film. Many of them enabled by producers that are making equipment that are represented here today, some of which they have just figured it out on their own. This is a large number and should be accounted for. This is my last point I want to make about the economics, and I mentioned earlier, is that the real opportunity here is as costs and prices move. So what's happening with thin film is because you've got to increase, as a producer, you've got to increase your volumes quickly, and you've got to get adoption from your customers. It probably is true that you'll have to price under the long-term pricing curve. It means that you can't just offer the same thing as crystalline, even when you derate sort of the value of a module for the efficiency loss. And that's what essentially this yellow line does. It tries to equilibrate sort of the balance of systems cost to figure out what should the module sell for at the different efficiency levels. The slope of that line, if you just want a rough rule of thumb, is 10 cents per point of efficiency differential. So if I have a product that's say 14% efficient, and you've got a product that's 11% efficient, that's a 3% efficiency differential. My product should sell for 30 cents a watt more at the ASP at the module level than yours. It just accounts for the fact that you need less area, you need less cabling, you need less racking, you need less installation labor theoretically. And that goes down over time. But you can see why First Solar was such a powerful offering, is that if you equilibrate everything onto that value line, and you look at the crystalline stuff in 2000, and I think this is 2007, you can see why everybody wants First Solar modules. They're just cheaper. They're cheaper even when you take into consideration the efficiency differential. And then you look at this is their selling price, but this is their cost. There's the reason that they can sell them so cheap is that their cost is so low. Well, we run this out to 2010, and we try to figure out who's got pricing power and who's got real market advantage. And if demand doesn't equal the supply in 2010 or 2012, where does it go? Who's got the most leverage? And we think that fundamentally thin film technologies, if they can hit the benchmarks of First Solar and some of the other cost benchmarks that we've got in 2010, really do have an amazing opportunity. But the proof of the pudding is always going to be in the eating. And we're going to need to see real bankable modules. Bankable meaning you can get financing on systems that use those modules at these costs, and thin film is going to be a real story. And I hope that that's what we're going to find out a little bit more today. Anyway, thank you for your attention.